Hi, this is Miss Pellegrin, and today we're going to be looking at Module 4, Lesson 6, Fluency with Percents. Our student outcome today, students solve various types of percent problems, identifying the type of percent problem and applying appropriate strategies. Our opening exercise this morning was to solve the following problem using mental math only. Be prepared to discuss your method with your classmates. Corey and Everett have collected model cars since the 3rd grade. Corey has 80 model cars in his collection, which is 25% more than Everett has. How many model cars does Everett have? Okay, so we know we have our part, our percent, and our whole. And so 25% more than Everett. And so that means that Corey, we're going to represent by 125%, which would be 1.25. So we got that. We did 100 plus 25, and then we moved that decimal 2 places to the left. And we want to know how many Everett has. And so the part would, we want to know how much, we want to know how much Everett has. So Corey has the part, he has the 80, which is more than our whole. So our whole should be less than 80. P is equal to percent times the whole. The part is 80. The percent is 1.25 as a decimal, and then X is our whole. Divide both sides by 1.25. So 80 divided by 1.25, we get 64. Does our answer make sense? Yes. 64 model cars that Everett has. Everett has 64 model cars. And he had less than Corey because Corey had 25% more than he did. Okay, example 1. 75% of the students in Jess's class are 60 inches or taller. If there are 20 students in her class, how many students are 60 inches or taller? So we don't have the word is, but we do have this word of. So 75% of. So that means we're multiplying 75% times the number of students in her class. And it does give us that information. It says there are 20 students in her class. So part, percent, and whole, we're taking 75% of our whole, and our whole in this case is 20. Okay, so we're able to fill in both of those, so we know that this has got to be our X. If it said 75% of and it didn't tell us the whole, then we would be able to say that the part was the other number we were given. P is equal to percent times the whole. So part is equal to percent times whole. So X is equal to 0.75 times 20. 0.75 times 20 equals 15. X is equal to 15 students, and that does make sense that there are less students, but 75% is a very good bit of the students, so 15 out of the 20, that does make sense. And if you actually divided 15 out of 20, so 15 out of is our division sign, 20, we should get 0.75 as our percent, and we do. So good way to check that. So 15 students are 60 inches or taller. Okay, Bobby wants to leave a tip for her waitress equal to 15% of her bill. Bobby's bill for her lunch is $18. How much money represents? So we're looking for 15% of the bill. We don't want to know in total all she's going to pay. We just want to know 15%. We just want to know 15% of. So we want to know 15%. So there's the percent of. Of is our whole of the bill. So the bill was 18. And so P is going to be our X. So part is equal to percent times the whole. The part is X. The percent is 0.15. And then the whole is 18. So 0.15 times 18 equals 2.7. But remember, it says how much money. So $2.70. X is equal to 2.7. But when we actually write our answer, we definitely need to make sure that we clarify the tip is $2.70. That's what we were looking for. So if they then asked us how much was it all together, we would add 18 plus 270 gives us $20.70. Okay, exercise number 1. Express 9 hours as a percent of 3 days. Okay, so first of all, I'm noticing I've got 9 hours and I've got 3 days. But I can't convert 9 hours into 3 days, so I need to convert my 3 days into a number of hours. So we're going to do 3 times 24 hours in a day gives me a total of 72 hours. So that's what we're going to actually work with. We need to make a conversion here first. So part, percent, whole. It says make a percent, so we don't know the percent. And it says of 3 days, which we said was 72 hours. And our 9 hours then is going to be our part. Okay. P is equal to percent times whole. Part is 9 is equal to percent times the whole. Divide both sides by 72. Whoops. 72. So 9 divided by 72. 9 divided by 72 gives me 0.125. Is equal to X, and we were looking for a percent. So 1, 2. So we have 12.5, or you could round up to 13, but it's more precise if we say 12.5%. Okay. Number 2. Richard works from 11 a.m. to 3 a.m. His break is 75% of the way through his work shift. So 75% of his shift. What is Richard's dinner break? Okay, so 11 a.m. to 3 a.m. So we need to figure out how long his shift is. So we're just going to count 11 to 3 a.m. So 11 a.m., 12 p.m., and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I'm at 13 hours. And then 1 a.m., 2 a.m., 3 a.m. So that's 16 hours. So that's his shift is 16 hours. That's a very long shift. 16-hour shift. So we have our part, our percent, and our whole. Okay, so the whole shift is 16 hours, and it said 75% of shift. So shift is going to be our whole 75% of this amount. So this should always be this percent of this amount. And then this is going to be our part. Part is equal to percent times the whole. So part is our x is equal to the percent times the whole. So 0.75 times 16. 0.75 times 16 is equal to 12. So x is equal to 12. So after 12 hours, that's what we were finding out, was after 12 hours. So after 12 hours of work. So at 11 p.m. he will have his break. Okay, number 3. At a playoff game, there are 375 or 70 fans cheering for School A and 555 fans cheering for School B. So I've got School A has 370. School B has 555. Express the number of fans cheering for School A as a percent of the number of fans cheering for School B. So part is equal to, or part percent and whole. Okay. So as a percent of School B, so my part has to be 370. Part is equal to the percent times the whole. So our part is 370. Percent is x, and our whole is 550. So we're going to divide both sides by 550. Whoops, not 550. Why am I writing that? 555. It's always best when you catch your mistakes. Whoops, I put it right here. Okay. So 370 divided by 555. 370 divided by 555 equals 0.6 repeating on forever. So we're going to say 0.66, and it's repeating on forever, and they're both repeating on forever, equals our x. Because we want to change it to a percent, so let's put both of our numbers here because we know we have to move the decimal. So we're going to go 1, 2 places to the right. Actually, in this case, it'd probably be better to have 3 here that are repeating on forever. Because we need to either say it's 66.6 repeating on forever percent, or we need to know that we're rounding to 67%. Okay, and not leave it as 66. So this is correct and this is correct, but if you had it as 66%, then you would not have rounded correctly. So either are acceptable answers, but make sure that you do round it correctly. Part B, you are going to be able to see in part 2 of this video.